just want to welcome everybody to the third webinar. This is the Spring 2024 ModelShare Workshop Series. It's organized by the Certification Working Group of the Open Modeling Foundation, which is an international federation of scientific organizations dedicated to community standards for computational modeling across social and natural sciences. I'm Michael Barton. I'm the Executive Director of the Open Modeling Foundation, and I'll be moderating today's session. I've got a number of announcements to start with. So we want to let you know that the Certification Working Group and this workshop follow the Open Modeling Foundation Code of Conduct. This is linked to, you can see it if you want, in the Google Doc, which is in the chat, and Ismail will be putting that link up there regularly for people who are coming in. Inputs from the panelists and participants are going to inform at least a planned white paper that's going to be written by the Certification Working Group and coordinated by the working group chairs, Chris Erdman, Sandra Gessing, and Ismail Karobi Garcia. So kind of just logistics for this, I'd like you to use the raise hand button to speak when we have audience participation. But in the meantime, please mute your audio when you're not speaking. And that avoids having dogs barking in the background and things like that. Feel free to communicate in the chat or add notes to the Google Doc that's linked in the chat. So we're going to start out with some opening statements from our panelists, Lauren Cadwallader and Lars Holm Nielsen. Lauren is the Open Research Manager at Public Library of Science as PLOS, and where she promotes open science practices and research communities that publish with PLOS, particularly for data and code sharing. Lars is the head of open science repositories at CERN IT, where he leads the open science services and projects for large-scale scholarly repositories. And he's the founder of one of these, Zenodo, this open access repository for all kinds of digital information. Their opening statements will be followed with a few comments from Jason Papin and Feilim Mac Gabhann. They're deputy editors-in-chief of PLOS Computational Biology, and they'll offer an editor's perspective on these. And so in order to make sure that everyone on the panel and in the audience has a chance to participate, Ismail says he's going to strictly enforce speaking time limits. And given that, I'm going to end my introduction here and turn it over to Lauren.
Thank you very much, Michael. I'll just share my screen. Okay, yeah, brilliant. Okay, thank you. I'm going to talk a little bit today about some work we've been doing at PLOS around kind of code sharing in the broadest sense, and some things we've learned, some things that we're kind of trying to piece together when we talk about publishing models and code more generally. For those of you who aren't familiar, PLOS is a non-profit, open science-driven publisher. We publish in primarily kind of life sciences, health sciences, but we also publish PLOS One, which is a really broad interdisciplinary kind of wide scope journal. And everything we do is kind of focusing on rigorous, transparent, open research. So over the last number of years, we've been conducting a number of different kind of initiatives around kind of code sharing. And if we think about this as a kind of basic publishing kind of workflow from research happening and then the research coming to us, we've been trying to look at all the different kind of points and think about what we can do to work with communities to ultimately promote sharing of all outputs. So some of the things we've been doing are kind of survey-based, talking to the authors, trying to understand things like why they might create a notebook in order to share the computational work they've been doing, or actually how they like to look at code as a reader as well as an author of articles. We've also run a pilot that looked at peer review of models. We've introduced a mandatory policy at PLOS Computational Biology, which requires code to be shared. And we've developed something called Open Science Indicators, which is a way of measuring practices of sharing of these research outputs like data and code alongside a published article. So we're kind of really trying to use all these different inputs to build up a picture of how artifacts are shared alongside publications, and I want to talk about a couple of them today. So I'm mainly going to talk about the peer review pilot we did for models, but also I'm going to touch upon the code policy that we introduced and some of the things we learned about how readers like to engage with shared outputs. So the model review pilot, so what was it? It was an opt-in extra technical peer review for manuscripts that were based on biology or physiology-based models. And this was conducted alongside kind of like the regular peer review you would get of a manuscript submitted to the journal. It was done as a kind of collaboration between PLOS Computational Biology and the Centre for Reproducible Biomedical Modelling. And why did we do it? Well, we wanted to increase the transparency and reproducibility of the models without delaying the publication of the article that, you know, is kind of traditionally the main kind of research output. And as I was saying earlier, you know, PLOS is an open science publisher, and really everything we're doing is trying to promote that transparency and reproducibility. So this felt like a really natural kind of pilot for us to run. And so we did it in the summer of 2020. And, you know, that was a few years ago now. And what we're trying to do now is really try to put those learnings into place and think about the next steps and how we can kind of take this forward and really start to kind of turn it from a pilot into something that is more of a regular offering. So how did we do it? Well, manuscripts were submitted to PLOS as normal, and then they could opt in to this extra review. And so when they opted in, they were sent to the Centre for Reproducible Biomedical Modelling, and they reviewed those models against a checklist within a limited time frame. Now, the limited time frame was set because we wanted the review to be, you know, just that, a review of the model. The reviewers are finding, you know, if they had a lot of time, they suddenly were trying to fix the bugs in the model, and that's not their job. The job is just to review it to see if it works, and they can send back comments to the authors, and the authors can go away and fix things. So that time limit really helped them kind of stay focused and stay kind of within the scope of the pilot and the review process. And then editors who were assessing the peer review reports as well as this technical report were then given discretion as to kind of how much this technical report factored into the final decision making about whether to accept that article for publication or not. And so what were some of the results? Well, we had 71 opt-ins over the summer period that it ran. And that amounted to about 9% of all the submissions we had to the journal in that time frame. That's a fairly good number. I mean, not all articles submitted to PLOS Computational Biology are based on these kind of models. I know the guys from the journal are here, so I think it's probably about 20% of papers were probably eligible. So 9% is pretty good. And of those, 50 were then sent out to peer review. The rest were kind of desk rejected, so they didn't even go through to the peer review stage for the manuscript. And then I'm just going to share some kind of findings we did. Some of it, well, a lot of it's based on some survey work we did. We sent a survey out to the authors who had their models reviewed. Because of the kind of the time taken for the papers to go through the whole cycle, we didn't send the survey to all 50 authors. So consequently, we kind of got quite a small sample size back. So this just gives a flavour of some of the kind of attitudes towards the model review. We asked authors why did they opt in to the review. And happily, most of them did it because they support reproducibility. They think it's good for the discipline. A couple of authors were brave enough to say, well, I opted in because I thought if I didn't, you might think I had something to hide. So it's, you know, it's interesting to see why people were motivated to opt in. And, you know, it's nice to see authors are interested in getting feedback as well on their models and looking to improve them. We asked them how satisfied they were with the review. It got an average score of 8 out of 10, so that's pretty good. And 7 out of 10 of the respondents who answered the question said that the review was somewhat important or very important for improving their manuscript. So it looked like there's good utility of these reviews and that the authors are getting benefit from them. And happily, there was no increase in the time to publication. So as a publisher, that's something we're really keen to make sure that we're not slowing down the whole process. excuse me, by adding in an extra step, and happily that wasn't the case. So these authors benefited from an extra review, but without any of the negative consequences of a delayed publication. So what is it that's kind of stopped us going forward with this? There are a few challenges and considerations that are kind of taking time to think through, finding capacity to answer. And I think these all make really good, interesting kind of discussion points. So things like, how do we make it sustainable? Like, who is this reviewer pool? Academic reviewers are already asked to do an awful lot of reviewing for free. And so this is an extra step on top of that. So we really need to make sure that there's enough people who can fulfill that job. And then there are questions like, how do we make sure they're quality reviews? How do we make sure everyone's doing the kind of same amount of work on these technical reviews, because they are more technical? And then how do we make this scalable as well, so that a greater number of manuscripts can go through this type of review? So these are all big questions, and they're all kind of questions that are really key for us as a publisher to get right, because it means that we'll be able to offer this type of review consistently going forward, and making sure that it's quality and really benefiting the authors and science. So they're the kind of things we're thinking about at the moment, and hopefully, we'll be kind of moving forward with a more permanent solution around this kind of review soon, fingers crossed. So that's the model pilot review. I just want to touch on a couple of the other things we did as well, so you can start to see how we're kind of building a picture of sharing and from the different perspectives, and how this all feeds into each other. So one of the things I mentioned we did was introduce a mandatory code sharing policy at PLOS Computational Biology. And you can see here a graph of the code sharing rates before the policy and then after the implementation. And we already had a really high level of kind of voluntary participation in sharing of code. And this is kind of any code that's underpinning the findings, not just models. And then we introduced a policy. And, although we had a kind of natural increase over time anyway, it really sped up that increase. So we're getting rates of near 100% code sharing now. And I think this really demonstrates that you can introduce a top-down policy that's making something mandatory, and it doesn't put people off if the community is already really kind of accepting of open science practices. So I think a lot of people sometimes a bit cautious about implementing policies and demanding their authors produce more things. But actually, I think if the community are already there and they're happy to adopt these kind of things, or happy to do it without being asked to, then actually it makes a really strong case for then just giving, I guess, those final few people a little extra nudge that they might need to comply or to start sharing. And it really makes it a kind of community norm. And that's really great for science, really moving it forward. So I think in the right situation, policies work really well. And then I just want to share a few things about what we've learned about readers of kind of code. And I mean, again, using code in a really broad sense here. We ran a survey and we kind of didn't really define code. We kind of left it up to people to interpret it in their own kind of situation. So this could be models, this could be software, this could be kind of small bits of analysis code underpinning an article, but it's the kind of code that computational biologists are producing. And so we asked them, how often do you look at code? Because actually, if we're asking people to share it, it's a good idea to check that it's actually being used by somebody else at the end of the day. And actually, a lot of people look at code fairly often, if not fairly frequently. And so that's good, right? There's utility out there from sharing this code. And so we asked them, why do you look at it? And they can see a word cloud here of all the different reasons why people said they looked at code. And this is a free text box. And so when you start classifying them, about 70% of the people who responded in the survey, and this survey was like about 280, I think, responses, 70% of those people are looking at that code, that model, that piece of software to aid their understanding of the article. So actually sharing this output and sharing it well is really helpful for those people to understand the research in the manuscript. And that's a really important source of information. Almost half of the people are also reusing the code. I put reuse because it might be that they're just reusing snippets of that code. It might be that, some people even said, I really just like the way that they displayed their data in that figure. So I'd like to kind of do something similar with my data in a similar figure. Other people are kind of copying kind of more fundamental bits of the code base. But other reasons went around assessing the quality of the research. Fewer people are rerunning it directly, but other people are using it to discover new methods, new code. Some people are using it for teaching. So there's a whole wide variety of purposes for sharing out there, and it's great to see that lots of people want to use it, because ultimately, we're opening things up, not just to make things transparent, but to make things reusable as well. And then finally, we asked people, like, why do you find certain methods of sharing useful? And there were things like, they find if the platform uses versioning, or there's good documentation, there's long-term access, there's easy access. All of these were the kind of characteristics that people found really helpful from a platform where the code, the model software is shared. And I'm sure Lars is happy to recognize some of the characteristics that repositories like Zenodo provide. So by doing all this research, these different parts of the kind of that publication life cycle, we're beginning to really understand like how code is produced and shared and used by researchers at different stages. And this is all, I think, really important for us as a publisher who wants to kind of respond to what the community's needs and desires are around sharing their outputs and making sure that they're transparent and open, so that then we can think about the different infrastructures that are needed to help enable this, the different types of solutions, whether they're policies or kind of support or advocacy that the researchers might need in order to help them to share and to really enable that for others to then take away and reuse in whatever way they want to. So I hope this kind of gives you a bit of an example of the kind of things we're thinking about as publishers when it comes to models, to sharing those kind of outputs, and how we can do different bits of research to really try and understand that, and then how we might take that away and then kind of facilitate greater sharing and greater reuse. So I'm going to leave it there. So thank you very much.
Thanks very much, Lauren. I mean, that certainly was interesting to me from my associate with ComSysNet on this. I'm going to move it right on to Lars, pick up here and continue on.
Thank you. Share my presentation. There we go. And seconds. Just need my windows in order here. Okay. Yeah, so thank you for inviting. So I'm going to talk a little bit about Zenodo. And the first I have is a couple of examples of what can happen if you don't have a place like Zenodo. And, here's the laptop lost with crucial scientific data and many years of research work inside, or, burning university buildings with 800 offices in because of a short circuit in a coffee machine. But probably, when we're talking around software and research output, there's a big part that's just getting lost because it's not getting shared. It stays somewhere on a laptop, on a computer, on a network drive somewhere, and it's getting cleaned up at some point, or we move around so much in science that we don't remember where the things are. So Zenodo is really a place to share and preserve any kind of like research output. It's not so if we take PLOS as an example, right, that's for the publishing of the articles, but in Zenodo, that's where you can basically put all the other things that is a research output, but not a journal article. Okay, it works very simply that you simply upload the data. You can share anything, models, data sets, software, posters, presentations. So it's really everything that you can share on Zenodo, as long as it's some sort of digital output. You associate basic metadata and can add a lot more metadata. And I'll show a bit more examples later on what this other stuff. But essentially, the minimal metadata you need is what you need for saying this is a research output with a title, some authors, and when was it published. Okay. Then it goes online. You can version it and things like that. You get a DOI. That means you can kind of get it integrated in fully into the citation graph and cite it uniquely. We are very strong on linking all the different entities, so whether it's a grant, whether it's an author with an ORCID ID or things like that, then in the metadata you can provide most of this information, okay? So the other part of Zenodo is that Zenodo is really just a platform. It's a platform to share and preserve, but we are currently like 7 people running the platform. We are not the curators of the content and don't know about the content. So what we provide is a platform for sharing and preserving, but the curation has to happen somewhere else. So we have this feature called communities, which is essentially self-organize your area, so that whether you have a project, whether you have a domain or things like that, you can set up one of these communities. And here's some examples that I found today while looking for something related to modeling. But essentially, it can be anything from a small research group to a full institution to what we have now, for instance, as well, is that the European Commission has a big new branded community on Zenodo where they now have 100,000 records in there and really a little bit of different UI on the thing. So this is something that allows you to organize, review all the content that you're gathering on Zenodo. Today we have 400,000 users across 9,000 organizations in 161 countries. So the biggest institutions, I think, is about 700 individual users. So we really have a very large spread over many different institutions. Okay, when you look at it. Then I've taken an example of how we do FAIR. And unfortunately, I don't have a good example from modeling, but it's from biodiversity instead, where we're working with some biodiversity researchers. And one of the issues there is that they put out PDFs, lock up the data inside the PDFs. So, they will describe a biological species. Here's just one example of it. And then inside there's a lot of data about geolocation, time of what material was investigated. And one of the issues here is really that you can't query on this stuff. You can't say, give me everything in a specific area of Earth with a spatial search. You can't say, what is the output of my collection? My natural history collection. Okay, you can't do these kind of searches. So what we're doing there is that on Zenodo, we're now allowing biodiversity metadata, and we have a collaboration with a small Swiss nonprofit where they're in charge of basically putting in a lot of domain-specific metadata, so that you can do these kind of searches that I just highlighted. And that's also in terms of tagging things with specific vocabularies, associating extra metadata files. So this is files where when you upload something on Zenodo, you can't change the files afterwards. But these metadata files allows you to provide a description of the record in a completely different format than what we support on Zenodo. So this is really a way to have a generalist platform that is able to handle domain-specific metadata and make it searchable and make it available. I would be happy to learn today of how we can better support the modeling community with these kind of things. Then another key point is that Zenodo is really just a place to share and preserve it. It's not the final place to find the things. So the example from biodiversity is also that we basically host and make sure that it stays available, whereas the data is actually being made available in biodiversity PMC, in the Global Biodiversity Information Facility, and lots of other places. So it's really a place where you can also put it in and get it distributed out to other places that makes the search improving how it's being searched. And here just an example of how this figure of the image was extracted. It was tagged with biodiversity terms, and it was then made available here in the Global Biodiversity Information Facility. Then on another area in the software area, we've long had, I think actually, it must be 10 years now. In March, I think it was March 2014, we released the GitHub integration on Zenodo. So that's really a way that when you have software in a repository on GitHub, you can easily get it archived on Zenodo and track the different versions. And some years ago, we had a project together with NASA, ADS, and American Astronomical Society, where we were also looking into how can we track citations to software once it comes in. Once you have a software in many different versions, and you issue a DOI to each one of them, how do we make sure that we then can count the full picture? And together with them, we basically have a method. So you can see here how we're able, when you have software in Zenodo, to track citations to all the different versions of a piece of software. And here you see an example from it's a little bit older example, but it's an example of how citations change over time to a specific version of a piece of software. So you can see you have here one version that gets more, and then suddenly the blue one takes over as the one being cited. Okay, so this is some of the things we do on Zenodo to try to really show the impact of research software. The other thing is that, as I said, we are pretty, we focus a lot on that you can link to all the different things. And once you put, so this means you could link the model with the software, with the data set, with the paper that described it. And one of the areas why you would want to do that is that it then becomes machine readable. So this is something that gets registered in DataSite, and you can then find these links between papers and software in an automated way. The other area is now that on the software area, we support some extra metadata fields now. As you can say, what is the programming language? Where is the repository hosted? And right now, we're testing an integration with software heritage. So that means that software heritage, that is source code archive. So they archive just the source code. And it's a bit like the Internet Archive for source code. So what they don't do, they don't, for instance, give a DOI to the paper, but by linking the two platforms together, that means that if you have some sort of software that is not in a repository on GitHub, you can share it on Zenodo, get the DOI, and we make sure that it then also becomes available in software heritage. This feature is, we're testing it out now, so it's in the sandbox, and it'll be available here later this year. Then just a little bit on Zenodo itself. So Zenodo is part of CERN. So Zenodo is a service from CERN. We're receiving the main part of the funding from the Commission and the National Institute of Health, Arcadia, and Sloan Foundation. Okay, but it's really the CERN infrastructure. And I think what's important to understand with Zenodo is that while we are only 7 people on the actual team managing Zenodo, then what we do is basically what we do for others, for our own sciences here in high energy physics. So we are relying on all the data infrastructure that we have at CERN, where we currently have, I think we just passed an exabyte not so long ago in data storage and things like that. Okay. The entire platform below Zenodo is called Invino RDM, and that's also openly available. And that's one way of how we also allow you to, not only is Zenodo a service at CERN you can do, it's also something where you can actually have a repository in your institution to have the same kind of features available for specific purposes. And that was all. We had 10 years anniversary here in May last year. So thank you for listening.
Thanks very much, Lars. It leaves me with some questions about how to link what you're doing with software citations to more general software citations. I think that's really good to get that Zenodo's working on this. I think we want to move along and have some brief comments from Jason Papin and Feilim Mac Gabhann on a kind of an editor's perspective on code sharing. So go ahead, Jason.
Okay, thank you, Michael. Yeah, so thanks for the opportunity to share a little bit of our perspective. I'm also here with Feilim, who's my partner with PLOS Comp Bio. And so I just have a few slides to try to kind of frame a little bit the way that we think about some of these principles that Lars and Lauren talked about. And the way I thought I would share this perspective, kind of introduce some of the concepts that we think about here, is by actually sharing 3 emails that I've received over the last month. So first one, as an instructor, I teach a couple different classes, some undergraduate, graduate level courses at University of Virginia. And as part of some of these classes, I'll have the students work on going into the literature and finding a paper that reports a model of some kind of computational biology question. And this is just emblematic of the kind of emails I receive. So this is, again, from about a week ago. I've anonymized everything here from wonderful student. Good afternoon, Dr. Papin. I had a quick question about finding a model to use. Is there a place you would recommend finding this metabolic network model that's compatible with this toolbox we've talked about in class? And would you recommend someplace where I could identify a good model? I think what this just emphasizes to me is these students in my class, they just have a hard time even finding and getting to work a model to address the question. Now, I use that as a teaching tool to kind of emphasize some principles like openness, reproducibility. But I think, again, this email is just emblematic of some of the challenge with that. When in the end, what you want is for that student to focus on answering the biological questions, being able to wrestle with the model to answer interesting things rather than wrestling with it to get it to work. Another email from the perspective of a researcher. So I run a research lab, PhD students and postdocs, and this was an example email that I received a couple of weeks ago. Again, everything anonymized. This individual, this postdoc at this university, reached out and said that they, with some colleagues, were working on some models that my lab had published with this Chlamydomonas reinhardti. This is an algae. They're using that as a scaffold. Now, one thing that was challenging is this paper was published I think 11 years ago. And this person then asked, we tried to understand all the constraints you used, but there's this one parameter, the carbon dioxide uptake rate. In the model, under certain conditions, the parameter was set to minus 11.16. Now, in what we published, we had a reference for how that was derived, and but it was one parameter over thousands of parameters that were in this model. And this was one that came out, and they said, we went to the paper that you cited, still missing to understand how this constraint was computed. Can I get any hints? So we're talking about a paper from 11 years ago, and we went back and forth to try to articulate how we got to that parameter, tried to spend time for us to remember ourselves. But again, when it comes to reproducibility, openness, and this is an example from my own lab where we could have done better in order to facilitate and allow someone else to build from that. Now, one more example from the perspective of an editor now. This is an email that I received a week ago. Dear Professor Papin, so there's a comment that's been added. This person was a member of our editorial board. And it says the previous version of the manuscript did not provide sufficient detail on the model, and the code was not provided. And this was the response from the authors on their paper when this particular decision was being considered. Quote, initial description of mathematical may have lacked sufficient detail, especially for those unfamiliar with the cited references. This was a response from the author to this request for just more detail so that the model could be better evaluated and could be considered. So again, why from these 3 perspectives, and then I'll leave it open for Feilim to add any additional perspectives and comments. From a lot of the initiatives that we're working on at PLOS, resources like Lars talked about, from the perspective of an instructor, there's really nothing better than when that student can get excited about using a functional model to answer the biological questions, instead of really having to wrestle with finding it and getting it to work. From the perspective of a researcher, there's really nothing better than creating something that others use. Your own work has a vastly more significant impact when others are building on it. And then from the perspective of an editor, it's really the same 2 points, except just amplified because you're trying to address these kinds of concerns and facilitate this kind of progress for a whole field. So with that, let me give the remainder of the time to Feilim to add anything you'd like to on these points.
Yeah, these are great examples that Jason's given. And the first thing I want to say is, although Jason's used very specific anecdotes and specific emails you've gotten in the last month, I get those emails too. And I think probably lots of people in the field do. Like these are recurring issues for everybody, right? And so this all generalizes. One sort of additional perspective of that is as a reviewer, because even as an editor, sometimes I'm reviewing a paper. And so I've gotten into a situation where, I'm reviewing something, and probably all have this experience, and go like, you haven't totally explained this. I don't know how you're doing this. And so you say, you need to explain this better. And you send that back to the authors, and the authors are like, okay, so here's the better explanation that we need to add. And then that comes back, and now I got to review that. But recently I had this experience where it was like, you haven't explained how you're doing that, but the code was with it. And so I was able to just open up the code and see it, they've done it this way. And so I was still able to flag it as like, you need to explain this better, but it shortened, to me, I think it shortened the review cycle. It made everything faster. So that's good for me as a reviewer. It's good for the editor, for the journal. It's good for the author, right? Because now, because they've sort of shared everything, it shortens the review cycle for them. They get the publication out faster. The person graduates faster. All of the good things, and the material is out sooner. One sort of overarching thing that and Lauren touched on this, and I just wanted to sort of reinforce it as something that we definitely saw both anecdotally and sort of from the various surveys around things like the code sharing policy. People know what the good thing to do is, and they want to do the good thing. They want to do the right thing. So in our field, lots of people, as you saw from the data, lots of people want to share, and they are sharing. But still, there is a benefit to implementing the policy, as Lauren said, right? So it's fertile ground. The field is ready for it. But it's that little bit of an extra push, right, to get someone to do the right thing, to share that code, to have it in a state that's ready to be shared. And one of the things that I think I'm talking to people about it is, and talking to my own lab about it, and talking to other people about it, it's always harder to do it later, right? Once you've got the paper done and it's written, and then sort of saying, okay, but right now you've got to make sure the code is ready to be shared, or now you've got to sort of implement open science principles now after the fact. That's always a lot trickier to do it later. It sort of feels like it requires resources to do, and people are moving on to the next thing. So by having things like policies, not onerous policies, but just clear field approved policies that sort of codify what people already know is the right thing to do, and already sort of, in an ideal world would spontaneously do themselves, knowing that those are coming, just sort of gives people that sort of little impetus to sort of get the stuff right earlier, get it, start those practices earlier, and make sure that by the time they're submitting the paper, the open science principles are already there. They already have the code ready to share. It's already up. It's already available. And so I think that's been beneficial, and it just sort of requires this little extra push. So yeah, that's all I wanted to add.
Okay. At this point, I think we should start out and open the floor to questions or comments from the audience to our panelists. But first, thank the panelists and Jason and Feilim for, I think, these really interesting and perspectives that should be at least are stimulating in a number of respects, so certainly for me. So thanks very much, folks. So what I'm going to do is watch the list of participants and see about raised hands, and call on people who would like to have a question or make a comment for the panelists at this point. Of course, you can also add things to the chat and add things to the Google Doc that's listed in the chat. Floor is open.
You do have some questions, Michael, in the chat.
Yeah.
Oh, in the chat. Okay, I'm watching for someone raising hands on this. Okay, so here is back up on the, see if there's one more come up. Okay. All right, so from Rebecca Ringat, I'm acquainted with modeling in space weather, not these fields where codes can be tens or thousands or even hundreds of thousands of lines long. How would these benefits be affected in those situations? What would be the reasonable to pursue them? Any thoughts from you folks? Or maybe Rebecca it might be a question about clarifying this a little bit.
Sure. Can you hear me?
Yeah.
Perfect. Yeah, so I have never written modeling code in my life. I am in the field with a lot of people that do these things and have done them for decades. So what I am doing is I am working in open science in this particular area of science and trying to see what is reasonable, particularly for modeling codes in this field. So there is a lot of legacy code. The community is, they are ready and working towards transitioning to open source. So there is that positive. But I'm looking for what is reasonable here. The comments I'm typically getting back about fair and openness for the code, even when it is open, is what's the point of having our tens or hundreds of thousands of lines of code to be open and out there? Fine, we can throw it at the wall, but you have to install it on high performance computers in a specific way, and it's designed for the one at our institution. So their pushback is, what's the point? How would anyone else benefit from this? We don't have time to annotate tens or hundreds of thousands of lines of code. So I'm looking for some input from this community on what that might look like.
I'll just add a perspective. I think one comment, Rebecca, is I really think of openness, reproducibility as more of a continuum rather than a binary, like it is this or it is that. I think that's important perspective because, for example, when we implemented the code availability policy, we did not prescribe where the code was deposited, even though that was part of the conversation that we had, because different fields had different expectations and kind of practices. And it was more important that someone share it somewhere rather than they share it in a particular way. Now that it's been so widely adopted, maybe we move a little bit further to make it more prescribed in terms of how. But I think that's one comment I'd make, is to think of it as a continuum. Movement in that direction, I think, is almost always positive. The other comment I'd say is I would not underestimate or underappreciate how making code and models available can be. People go through that material more than I think I anticipated. And the one example I shared, where that person found that one line in that one supplemental file and was trying to wrestle with that, was an example to me. And sometimes you don't know how useful it can be until it begins to be shared. So I'll stop there because I see other comments.
Thanks. Chris, and then Lars, and then maybe I can't figure out how to raise my hand, which is interesting. So
Just do it physically.
it's not showing up on this. So anyway.
No, luckily before we had this call, I have formerly worked at AGU, the American Geophysical Union, and I had the fortunate opportunity to talk to the modeling journal, James, chief editor there. And we worked together in the past with all these big modeling challenges, like you said, Rebecca. We actually talked to some of those communities, and I think one thing was like, they get these policies about sharing everything, and then that sort of creates friction already from the start, and that comment comes out already like it's so much work and what's the value. And we kind of had to meet them in the middle and just say, in general, that sharing some of your code, giving sort of a general understanding, and so not sharing everything, but giving the parts that can help others sort of understand the research was where we were sort of meeting them. And this generally, like we were talking about whether this is something that needs to be communicated better, maybe from editors, that experience this problem, but like trying to meet, communities at this point where like you share some of your code and gain an understanding. But we were also concerned about this having a detrimental impact on everyone sharing their code, like that the full code. And so it's a communication challenge, right? Of trying to help people sort of understand what exactly this is and what we're asking for. And so I hope that helps, but I think we do need our help from editors like Jason and Feilim, and the editor that I mentioned. But yeah, Lars is next. Sorry.
Lars?
Yeah, yes. So, I mean, I just want to subscribe to the idea that this is a continuum. It doesn't have to be perfect. It doesn't have to be everything at once. But then the other example I want to give is from high energy physics here at CERN, where we're sharing open data from the Large Hadron Collider, and we've been in some of the same discussions of why I do this. Why does it make? Why spend so much time on trying to open some of these? Nobody will be able to download these petabytes of data. And the fact is that, well, somebody did download it. Somebody did discover new things in the data that was shared. So predicting what can happen when you share, I think, you basically can't predict it, and that's also why you should be sharing it. You might cannot predict if they're gonna install it on a high performance computing system, or perhaps they're just going to actually look at a small part of it, right? So I think that's other arguments, that it really doesn't have to be perfect, and you don't know what's actually going to happen.
Thanks. My hand went down, but I'm going to assume that everybody saw it. And Jutta, you'd be next up to this. This raises a number of, I think, really important points, and it gets to the heart of one of the mission of the certification working group that set up this this workshop this spring, and so I think many people recognize there's some value to the larger community of sharing your code, and there's different values to that, and certainly it doesn't have to. It's not all or nothing. I agree that it's a continuum, but there does need to be some benefit for the people that share their code in order to justify the extra time and effort to make it available. And I think this is where groups like PLOS and AGU and others can be really important, so that and in fact Zenodo, so that when you get citations for this feeds back into professional recognition, professional rewards and things. So we can't expect people to share their code simply altruistically. No matter how much they want to, there's a lot of other things that ends up being prioritized. And so we as a community, I think, need to work together in order to help make it, both communicate the value of sharing code, but also help make it worthwhile for the people that have to do this work. And so it's great to see these different parts of the community coming together for this. Jutta?
Yeah, thank you. I have two additional thoughts on this. One is, in my experience, if you share the code, or if you are forced to share the code, you will clean it up and you will document it better, as it would be only in your own computer and so on. This is already a benefit, I think. And I see it also, Rebecca, you ask if it's 10,000 lines or whatever, and we do not exactly know who will download it, or maybe nobody will download it, we don't know. But on the other side, I see it a little bit like the what we call a trace document for ecological modeling, where you document, for example, also all the experiments you have done and all the documentations and so on. I compare it a little bit like these big manuals you have, for example, for lab machines, for gas chromatographs and so on. You would never ever read it, or you will not love to read it, but it's good to have them in the shelf, because if something is going wrong, if somebody is using the machine and thinks there's something very strange, then this person is able to open the manual and to check where it can be. And only to have this opportunity, I would see already as a benefit. I have an additional question to all of you. Because I think that many people are willing to share the code, I face another problem as a team leader. I have sometimes the problem that on one side, I would like to maintain the models and the code which is developed in our team. Also, I am forced by the European Commission or the German Research Foundation that I should maintain the code and the models for at least 10 years. But because of the short-term positions of my PhD students and so on, it happens from time to time, not seldom, that a PhD student has developed something, is gone in a new job, and after a while the model is gone as well. And this is for me also the hope, if it's in Zenodo or somewhere where it's documented, then it's better than to search it in all these machines where it could be. But of course, it's not a guarantee that it's still available and running for the next 10 years. So I don't know whether you have the same problems and whether you have some solutions for this. Thank you.
Thanks, Uta. I'm going to go to a question in the chat and then to you, Joe. This is from Brian Vestra. And so if I can understand this, is how do you deal with self-plagiarizing concerns for authors with regard to including methods with code and data that are also in a paper? So Brian, maybe do you want to clarify that question a little bit? I didn't quite understand it.
Yeah, I've had a couple of times just in the past couple of weeks where I'm trying to encourage somebody who's maybe reluctant to even share their data, and then working with them to share their data and then encouraging them to include methods description in their README file, which is going to help discovery of that data set, but also for code. And they've come back and said that they're concerned that they might be accused of self-plagiarizing because they're reusing a method statement in multiple places. And that may sound extreme, but then they showed me some editors' comments about a paper that they were submitting where their methods weren't significantly different enough from a previous paper. So I know there's some conflation there. I'm just wondering if other people have encountered that, especially from a publisher or editor perspective, and how you go about addressing that. I basically said, maybe you just need to talk to your editor and see, what you can reuse and how much is plagiarizing, Does that make sense?
I find it kind of weird that they're being accused of self-plagiarizing when they're making their code available with a description. But anyway, that's a good question for the editors here.
Yeah, I mean, I don't think there's any question. I mean, absent sort of special circumstances, I don't think there's any question that, reuse of a model is something that we should be supporting, not preventing. It's whenever thinking about sort of computational methods, I often sort of go back to, I try and make an analogy to experimental methods and think about how that might be done. We wouldn't sort of accuse someone of plagiarizing a Western blot because they are doing a Western blot, right? So reuse of methods should be a positive thing. And I've always thought of it as actually, if the model is already published, it actually kind of shortens the writing and because now you can cite it and then you can build on it and then you can do all of those things. It is obviously, of course, if the model is not theirs, they need to be really clear about the sourcing of it, right?
Sure.
But if they're, building, as people often do, building a model, over the course, building and expanding a model over a course of multiple publications and sort of expanding and building and adding applications and new insights. I think the sharing of the model is intended to be supporting that reuse and supporting that reproducibility over time, as opposed to, any sort of obstacle to, publication of further work based on based on or largely based on the same model.
I'll just to Feilim's comment. Just my feeling is that the scientists, the authors in the field appreciate that point, that the goal is for the model to be refined, updated, improved. And so they wouldn't think of it as self-plagiarizing. Where I see those concerns come up is more when someone who's more orthogonal to the field and isn't really working through how the field practices on building the models. But
thanks. I concur. I just, it was hard for me to figure out if it was just a red herring or, if this is something that comes up. It was really more about the methods statement. And I just assumed if you said this was, this is a method, we all use this same method, why it would be an issue. So thanks.
Yeah, I've heard as from putting on another hat of a place where people do publish models at ComSysNet, some people are concerned that others might plagiarize their code, and so this is why we need to encourage open source licensing for all code that's published like this, and also strongly support the ethic of citing code that you use in the same way that we cite other resources that people do. So I think that's really important. Joe?
Sorry.
There you go.
This is I guess a bit of a comment and a bit half-baked, but sort of to Rebecca's question and point on sort of like what's the point on doing this? Full disclosure, I work with Feilim and Jason and Lauren at PLOS, but I think from my experience, it's been really interesting seeing that open science really moves as a consensus. I've talked to some people who say, well, I don't really want to do it until my institution makes me have to do it. I'm the one person in my department who's sort of the truther about this, and I tell all my friends to do it. And I think the answer really comes from both directions. And I think there's kind of a couple examples that I'd like to point to, which is, for example, the Harvard School of Public Health. They have I think it's called the Chan Review. They have a institutional reputation, practice, familiarity with doing code sharing, and that's something that comes specifically from the institution. That's only one part of the institution. It's not Harvard as a whole, it's specifically the School of Public Health. And then, it's really interesting to hear sort of the things that Zenodo is working on, because from a publisher's perspective and sort of managing the journal, it's really helpful to have, one of the issues we have is consensus on what is essentially the Facebook, what is the critical mass of, to Jason's point of where can I point someone to go, particularly newer people entering the field, I think, where younger folks are sort of more used to aggregated data and aggregated sort of results of things, whatever that is, that sort of seeing Zenodo as a place, if we could get Zenodo to be the place where everyone across all fields can point to say, this is where your code goes, everyone is familiar with the practices of Zenodo, what's required in terms of annotations when you do it, like that would be sort of the dream state for me. And so to see the work that they're doing regarding to sort of like improving the metadata attached to information is awesome. And it's just sort of, I think, a community effort that as instructors, as people of influence, that's, we sort of all support each other's work and saying, we are going to try and get consensus that Zenodo is the place we all share our figures, and that we all sort of like do our part to encourage the people around us to do open science, because it's not really just going to necessarily come from just the top or just from us. It really does. It's a lot of consensus building as an activity I've kind of seen. So that was really just the comment I wanted to get out. And I'd say it's also reflected, ease of use, for example, is the biggest barrier for us. If you're looking at reasons that people will or will not share code, it's typically got to make it easy for people as possible.
Let's see, I'm going to try. I think, Tatiane, do you want to, I think it's better if you actually express it than me try to reach your question here.
Yeah, thank you. Can you hear me?
Yes.
Yeah, I think my question goes a little bit in the direction of the difference between just publishing your code and actually keeping it working in the long term, especially. I feel like a lot of this might end up at the hands of the PhD students and the postdocs, or might be expected to end up at the hands of the PhD students and postdocs. And we know that in the world as it's now, postdocs go from one contract to the next in 1, 2, 3 years. And then I fear that this code just gets lost and doesn't work anymore after, if it worked at all after publication. So I'm wondering if this is not something that it's important to try to tackle somehow. I know that it's a huge problem within academia, but I'm wondering if this is not something that might still hinder the adoption of good modeling practices in the long term, if we don't have a plan for example, for ecology. How can we actually have somebody that can maintain code in the long term? It goes a little bit with Uta's question. I don't know, I just wanted to know if anybody would like to add any more opinions on this front. Thank you.
Mm-hmm. Rebecca, I see your hand up.
Yeah, I've been thinking about the same thing. So in space weather and heliophysics, there are so many different modeling codes, right? I'm sure it's the same in every field, but we have to come to terms that, while I think all of the codes are worth sharing, not all of them are worth maintaining. So committing to maintain every single software code long-term is simply not going to be feasible, even just for the field that I'm familiar with. So I think the question of what to maintain, how detailed to maintain it, right? I think that comes down to funding. And maybe that should be a competitive process so that we're not demanding everyone that writes code to maintain it forever. But that the community decides what codes are worth funding for long-term maintenance. I push that to this group for opinion.
Lauren, and then Lars.
Yeah, I was going to raise a kind of similar point that I think funding has a part to play in this, kind of both funders and institutions. And I know that some funders, at least in the UK, are now willing to fund positions like research software engineers, so that you have a dedicated person who can look after your model or your code. And I think that kind of acknowledgement that kind of open science doesn't just happen alongside all the other research that you're doing, that actually there needs some dedicated resource to that is becoming more accepted by funders. I mean, especially in Europe, and perhaps that needs to catch up elsewhere in the world. But there's also the role of institutions around teaching good practices around code. So that kind of basic work of annotating it and stuff happens as you go along. So I think there are lots of different stakeholders that have parts to play in the kind of establishment of those basic really good practices that kind of hopefully set you up to then be in a good position when it comes to publishing. And then it's more of that question of that kind of routine maintenance rather than having to annotate the whole thing right when you get to the point of publication.
Lars?
Yeah. So the other aspect of funding is that you can also, it's really about the community building as well. That's another way to maintain some of these products. And I think the skills you need to build the community is very different from what you need to engineer the software. And that's, I talk from my own experience in trying to set up the Invenio RDM community as an open source community, building the platform behind Zenodo. And maintenance costs money, and we're getting funding from grants to help build stuff. We're getting funding from internally at CERN. We're getting in-kind funding through the having a community behind the platform that helps build it up, right? So it's just another way that you can help try to maintain the software. But without the maintenance, if you just leave it there, it won't run again. There's examples for soft platforms that try to do it, but even the platforms themselves have to be maintained. So it's really not an easy thing, but I also don't think we have to be perfect.
Yeah. Rebecca, is your hand still up, or is it up newly up?
I apparently left it up. Sorry, I'm not on my usual device.
That's all right. The other thing I just want to make one point is that there's different kinds of goals in sharing software, right? So there's one thing where you want to make software available to distribute for people to use and have a lot of people use it. There's active open source software for this. But there's also, I think, a lot of what we're talking about here is making code available as a record of what you did in research and how you did it. just like you would with a publication. And yes, that can be dated 10 years down the road, but that still is if it's well documented, it's still a record of how you did it and what you did. And even if that particular piece of code will not actively run today, someone can go and look at it and understand the computational research that you did. That's one point. And so maybe we don't need to worry quite so much about having to maintain every piece of code forever. The second is if you do something and you think it's important that people are able to not just read your code and understand it, but actually be able to operate it in some way. There are tools like containerization that are out there that allow you to kind of make your code usable well longer into the future. Even though platforms may change, you encompass all of the libraries and dependencies that are needed to run that code in a container so that it's actually accessible and usable in that point. So there's some different kinds of alternatives to that we can think about for that. Sandra?
Yeah, I really love the discussion because we're looking also into not only with the certification group, but also with USRSE, the US Research Software Engineer Association, how to make it really also for career paths, for example, better if you publish code, because nowadays most in academia, at least, it's around publication, manuscripts, papers. Maybe it starts with data sets a little bit that really organizations want to incentivize that, but software is still not there and models are still not there. And I think really helping with publishing it, increasing, the track record of having created software that one day, and hopefully not so so far in the future, that it can be really used also as for career paths, for saying, okay, I have this publication, but I have also really this model and software packages. I think publication is the right way and to increase the quality to do that. And the other thing is all these different, also really, let's say, for publications, if the publishers are aboard and the repositories, and we can do some certification, some badges, it will take some time, that it will be really valued by the whole community, but it's a good way to start. Somewhere we have to start. Cultural change is not easy. So small steps are the ones, if we can do it now, I think it gives us the first baby steps.
Thanks, Sandra. Are there other questions or comments?
I think there were still some in the chat further up, so maybe someone who had a question there and feels like it's not answered yet might want to raise their hand.
Yeah, so I could well have missed something trying to go through them.
We're definitely going to have to save the chat.
Yes. Merlin, I see a hand up.
Yes. Yeah, you can see me now. Thanks. I would love to bring in the perspective of a government agency where I'm working. Yeah, and for us, like, it's really important that we as non-experts can see how valid is the code or the programs, how robust are they. They need to be like long-term reliable for 10 years or more. We need to be, or we are accountable for the results we produce with the code. And yeah, we don't have the capacity and the knowledge to do this evaluation. So this would be like really big help for us, I would think. And the benefit of open code, from my perspective, like, we are working in nature conservation and resources, financial resources are always scarce. So if code would be developed in a project, it would be really cool if it's open and others can build upon it and also feed it back to us. Yeah, so maybe so much to that.
this is also benefits from the kind of peer review that Lauren talked about, that PLOS is piloting. ComSysNet also has a peer review section where code can be peer reviewed. And so I think that's, these kinds of institutions or activities are all necessary to help with making sure that we have some confidence in the code that's available, that it's understandable, that it's usable, and serves its purpose. Sandra?
Yeah, I almost wanted to say something very similar. So Michael, I fully agree to you. And the other thing, I think we all know peer review is really important, especially also for funding and yes, agencies to have really the experts there. So it's great that we are having now with the publisher these projects and everything. I still also would like to talk maybe about the peer review. I think because of the lack of having a better system, is peer review the best what we got? Are we any near maybe to have more ideas about how to give badges, certificates without peer review? Would there be a way to do this? I really don't have the answer. I really don't know. Because I think peer review is the best we have, but we know that it has also its pitfalls. So,
Lauren?
Sure. Well, we've been kind of experimenting with a bit of that, I guess. So we've tried this model review. As I said, we're trying to work out how to kind of scale that up. We've also been trying something, we called it accessible data because it started around data sharing, where we gave just people a kind of, it's not quite a badge, it's like an icon that sits alongside their article, and as you scroll down the article, it moves with you. And it's more of a button where it says see the data, so you can click on it at any time in the article and it takes you straight to the repository record. And so we did it like that to kind of facilitate and enable people to reuse the data rather than just take them to a certification page that says yes, the data has been shared. And so we've expanded that, so it includes things like GitHub now. It's always included Zenodo, I'm pleased to say. And it's actually, that's been a really interesting exercise, actually. People and authors seem to really like having these kind of little buttons on their articles. So that seems to be incentivizing people to share their data, and it's linked to using a repository. We've expanded that to include code, and we know see the data isn't quite the right name for it now, but it's still slightly in an experimental phase. But that doesn't give any accreditation around quality. So that's the kind of missing piece in that. So it's more of a lightweight, kind of halfway there type of accreditation. So I guess it's getting people to start thinking about it. It's those kind of baby steps. It's just normalizing the process of making things open, and then we can start normalizing the process of maybe peer reviewers looking at the code. And I think sometimes we just have to take baby steps with these things to make it more normal, whilst we work out those solutions of scaling things up and trying to find the really rigorous in-depth ways that take a lot more resources.
I want to respond to Ricky and bring out kind of a related thing. And Ricky mentions astrophysics source code library, which is another one of these places that have maintained code that are specific to certain disciplines. I want to point out that not only do we need to have some assessment of quality of the code, but some assessment of the quality of the repository to make sure it's in a good place. And so point out SciCodes, a consortium, has been trying to come up with a set of criteria, and then for what makes for a trusted, persistent code repository, and then provide a list of these as different groups meet those criteria. So this is another side we haven't thought about a lot, but what is a good place to put your code so that other people can get it? Chris?
Yeah, thanks for sharing SciCodes. Actually, I was going to mention that, but I know this is a bit of the future here, but I did want to share something, which is this is a group called DSci, Decentralized Science, and they're developing there's this thing called decentralized persistent identifiers, and one of the examples is that they're building sort of their new form of journal, which has actually baked in these badges, these requirements for submitting to a journal. So, you know, you can go to the page and see what you need to do as far as data, or what you need to do as far as software. Another example, kind of like this, is NeuroLibre, but we're going to work with them at SciLife Lab to see, you know, like how can authors work, you know, in this way, and you know, really sort of push, move things forward. But you know, I think having this baked in right away, and you know, this is again something we talked to the editor at James, the journal at AGU. We were talking about how can you bake these things in, you know, like when you start essentially at the onset. And I think, you know, in a way, this can be seen as badges, right? That badging idea.
Mm-hmm. Thanks, Chris. Are there other comments, questions at this point? Well, maybe we should wind this up. I think it's been a really, really productive session, and hopefully inspirational to those of you that participated, and will inspire all of us to work together more as a community, not just to encourage people to share their code, but to make it easier to share, make it more worthwhile to share, and to try and start this virtuous cycle of making our research activity accessible to others in a new way, in a new world. So thank you all. Especially thanks to Chris, Sandra, and Ismail for organizing this and these workshops throughout the spring. I think I saw in the chat someone put up the list of the upcoming ones. There's going to be more, so keep tuned for that. Anything else you want to add, Ismail or Sandra or Chris?
So thank you everyone for joining, and thank you again to the speakers, of course. And so we will write a white paper after the series of workshops. So if you would like to contribute to that, yeah, we will reach out. We will have all the topics we had in the workshops in the white paper, and we probably start around June. We are not